Hello everyone, this is Simple Math for you, and today we are going to continue the special revision, and this is part 3 about transformation. أهلا بكم، واليوم سنكمل المراجعة الخاصة ببعض الدروس، واليوم سنراجع 3 دروس: reflections الانعكاس، translations الإزاحة، rotations الدوران. So we are going to revise reflection rules, translation rules, rotation rules, and we are going only to do some exercises for rotation about the origin. If you want other than origin, you can refer to the lesson in details. But in this revision, we are going only to find the rotation about the origin and counterclockwise. So let's start these questions. Triangles JKL has coordinates J03, K -2 -1, and L -6 -1, as you see here. You can plot them also to visualize more. Determine the coordinates of J03 after a reflection in the line x equals -4. Actually, you have here two options. Either you can draw it, you draw the line x equals to -4. So our line will be at x equals -4, 1, 2, 3, 4 in the negative side. This is x equals -4. And look at the J here and reflect J across this line. So count 4 units from here. You can count from J to the line of reflection. It's 4. So you can count 4 from the other side until you reach here. And if you find out what is the coordinate here, you will find it is -8 and -3. This is one of the options. Other option is to use the rule. What is the rule? Rule is just multiply this constant by 2. So it will be 2 times -4, which is -8. Then since x is the x equals to a number, then x will be affected. So this -8, you will subtract from the -8 the 0. So -8 minus 0, leaving the y the same. So you will just say -8, the new product, minus the original x, which is 0. So it's -8, and keeping the y the same. So that's why we will find out that we reach to the j prime -8, 3, the same as the one that we have obtained here. So it is like 2b minus x and then y. This is the relation. B or A, you can say A. A is the number that is given here, the constant here. Let's try here. Find the image of the point A01 under reflection of x equals to 1. So it's x equals to 1, keep the y, x will be affected. 2 times 1 is 2. 2 minus the 0, which is 2. So it's 2, 1. Done. Without even graphing. Point 2 minus 3 is reflected in the x-axis. What will happen if you reflect in the x-axis? X-axis means what will be affected? The y will be just reversed, opposite the y. So it will be x and -y. So what is going on here? Keeping the x the same, the -3 will become 3, so A is the answer. When M4 - 9 is reflected in the y-axis, the image will be where? Y-axis means xy, y-axis, this is y-axis, so the only change will be with x. That means it will be -x and y. That means this will be -4 and keeping the y the same, -4 and -9. K2 -6 in the line y equals -2, similar to the rule that we have introduced here. So 2 times -2 is -4. Y will be affected, x will be the same. So -4 minus -6. -4 minus -6 means 2. So the answer will be 2. If you want to sketch, go for that. What is the x-coordinate of the image when 4 minus 1 is reflected in y equals to 3? Y equals to 3, so 2 times 3, which is 6. So 6 minus 4, which is 2. So x-coordinate is 2. Y will be the same. That's why they are asking about 6 minus 4. No, sorry. No, Y will be changed. I'm sorry. 6, the Y, this is Y minus 6 here will be again 2 times 3, 6 here, minus 1 is 7. So this will be the same. So he is asking about that one. So X coordinate will stay the same. No need even to do these calculations. X will not be affected. I'm just finding for any purpose. Use the graph below. The horizontal distance from B minus 1,5 to the line of the reflection is. The horizontal distance is this distance. So simply count. 6 units. Use the graph below. Find the coordinates of the triangle after it's reflected in y equals to x. In y equals to x, simply what will happen? Just flip, interchange the x and the y. So let's check one of the coordinates. For the d minus 8 minus 5, it will be minus 5 and minus 8. So this will be the answer because it's the only one giving you this d prime. D prime is this one. So this is the correct answer. You can check others also, just flip. When the point xy is reflected in the y equals to x, the image will be yx. Muhammad has installed beehives at point ABC along a path. Muhammad wants to install a beehive at point F. Where is F? F is the reflection of point A across the path. Where is A? This is A. This is A. And this is the path. If you reflected, simply you can count here 1.5. So from here half and 1. So it will be here. So this is your F, the reflection of A. And if you find the coordinate here, it will be 8 and 6. This is one of the ways. You can find it this way, 8 and 6. Count from here and there. Other way is to find the equation of this line of reflection. Line of reflection has as an equation x equals to where it's at 5, as you see. It's between midpoint between 4 and 6, so it's x equals to 5. And if you want to reflect A, which is 2, 6, along that one, so just multiply the 5 by 2, which is 10. 10 minus 2, which is 8, and keeping the y the same. So we are reaching the same conclusion. You have two approaches to do that. Both of them are correct. If R 410 is reflected in line what, then the image is located as minus 8 and 10. As you see here, 10 remains the same. Y coordinates is the same. Y coordinate is the same. So what will happen? They are in the same level of Y, and the line of reflection will be exactly the midpoint between this part and this part. Yani it is in the midway between the 4 and the minus 8. So simply, if you are asked to find the line of the reflection when x changes, y is the same, just find the midpoint between the x coordinates. So it's 4 plus the minus 8 over 2. Midpoint is the sum over 2, which is minus 4 over 2, which is negative 2. And that means we are reflecting about or around x equals minus 2. And you can do it mentally, even without calculations. You can imagine that. Determine whether translation maps triangle JKL onto J prime K prime L prime. If so, find the translation. If it is a proper translation, then all the points should move equally. Same points or same number of units in the y direction and in the x direction. So we will check one by one. So checking from J to J prime, actually we will find that it has been moved 3 units up, 5 units to the right. Let's check the other one, K to K prime, 3 units up, 5 units to the right. We are starting by the horizontal, yani 5 units right and 3 units up. If you check the L has been moved to L prime same number of units, 3 up and 5 right. Since all points have been moved equally, that means we have kept the rigid motion, we have kept the same congruent, same triangle congruent to the image, and that means yes, it's transformation. When you write that translation vector, you start by the x movement, horizontally, left or right, then the y movement up or down. So we have been moved 5 units to the right, so it's positive 5, 3 units up, so it's positive 3. That means this is our answer. The image A, -2, -3, under a translation, so A was -2, -3. Under a certain translation, it becomes 7 and 4. So there is a translation vector somewhere here. We added something. If you want to find the translation vector, then subtract the final x, final y, minus the original x and the y. So we will subtract 7 minus -2, which is 9, 4 minus -3, which is 7. That means you subtract to find how much it has been moved. Why we shall do that? Because the same translation vector will be applied to B. Now B is 3 and -1. So under the same translation, we apply the same vector. Now we are going to add 3 plus 9, 12, -1 plus 7, which is 6. So the final result is this, B prime. So if you have the image and the pre-image, find the translation vector by subtraction, final minus initial. Then apply the same translation vector, so you should add it to the original to find the final destination. Find the image of Q. Now we have pre-image and we have the translation vector 1 and 3. So what is the image? Just simply add 4 plus 1, 5, 7 plus 3, 10. This is the final image. Find the coordinates of the image of the triangle after a translation along -2 and -9. So we will take one by one. We have M was -3 and 7. All of the points will be under the same translation vector, which is -2 and -9. So we are going to add to find the image. -3 plus -2, -5. 7 plus -9 is -2. Then we have P. Do the same thing. Add. So this is going to be added to everyone. Then N. Going to N prime. It will be -2 and -5. If you are asked to plot the points, of course you are going to plot them, but see, they are asking only to find the coordinates. These are the new ones. Write down the translation vector that maps ABC to A prime, B prime, C prime. Since we need the translation vector, so it's enough to find one pre-image to one image and see the difference. So if you take B, let's say B was how much? 5 and 5. It goes to the image B prime, which was -5 and -1. Since it's a proper translation, then it will be applied for all. So you just take one of the points. Now we need that translation vector, so we will subtract -5, -5, -10. Now the other point, -1, -5 is -6. -1, sorry, 1, this is not -1, this is 1. Yeah, this is 1. 1 minus 5, so this is wrong. 1 minus 5 minus 4. Yes. Sorry, yeah, I have copied here. This is 1, not -1. 1 minus 5 is -4. 1 plus, yani. 1 plus, 1 minus, yes. 1 plus -5 or 1 minus 5. It's better to subtract. Yes, that's it. So subtract The vector that translates C to C prime, again, subtract 2.1 minus, so 2.1 minus the negative 3.8, it will be 5.9. So we put 5.9. The other one, negative 4.3 minus 7.5, it will be negative 11.8, and you will put it here. Find the image of K, L, and J after translating along the vector 2, 3. So simply you are going to add this vector to each point. Let's check the first point, K, 1 and minus 1. Add 2 to 1, it will be 3. Add 3 to minus 1, it's 2. So K prime is 3, 2. The only one is K prime 3, 2 is this one. This is K prime. So this is definitely the final answer. No need to check others because this is the only one including K prime 3, 2. The graph of triangle ITR and its image I prime, T prime, R prime are shown below. Find that translation vector. Since both points have been translated equally, so we'll check from I to I prime. Let's see the vertical and the horizontal movement. Just check the horizontal and the vertical movement. How many units this I have been moved to the right? 1, 2, 3, 4, 5, 6 units to the right. So it is 6, positive 6. And it has been moved 1, 2, 3, 4 down. So it is negative 4. So the answer or the vector is D, definitely. Other way to do that is to find the coordinate of I originally, I prime finally, and subtract. You can do it also, and you can check. You will have the same answer, definitely. Given the triangle below, answer questions. Find the image of A and B. Now we are in rotation topic. After rotation 180 degrees counterclockwise about the origin. So 180 above the origin, just remember the rule. XY will go to negative X and negative Y. So simply you just flip the signs. So A prime will be negative 4 and negative 5. B prime will be negative 2 and negative 1. Just reverse the signs. Find the images after rotating 90 degrees. What happened for 90 degrees? XY will be what? Now interchange, yani Y, X, then change the first one. This is simply the way that I remember. So A prime will be what? A prime was 4, 5. Then after interchanging it was 4, then change the first one. Reverse the first one. Now B prime, it was 2, 1. Now it is 1, 2. And this has been changed. Last one in this part, 270. So XY will be. We will change as we have interchanged, as we have done in the 90. But now we will change the sign of the second coordinate. So A prime will be. A prime was 4, 5. Then it will be 5, 4. Change this sign. B prime was 2, 1. It will be 1, 2, and then change this sign. Reverse the sign. Simply, it's very easy. Since you know the formula, it is very easy. Refer to the figure below and answer the questions. The image of triangle A, so this is triangle A originally. After 270 degrees rotation counterclockwise about the origin. Where will this be? If 360, it will go back here, right? And now we want what? 270. So this is 90 will be this quadrant, and then 180, and then here 270. So it will go to triangle B. If it is 90 degrees only, so counterclockwise, it will be here. Only just rotated 90 degrees, it will be here. And 180 will be definitely C. Easy. Now, if you are not sure, you can take one of the points and check what is the difference. يعني check مثلا هذه البوينت, this point, this is the tip مثلا of this point, where does it go? You can check in quadrant 2, 3, 4, where will it go, but it will be more complicated as you see. Match the below. The transformation xy to negative x negative y is a what? One of those choices. Which one? It is definitely A. Rotation about the origin 180 degrees. Y minus x, it will be where? B, and this will be C. Very straightforward question. Okay, now moving to the last part, which is here, the part related to triangles and congruence. In this part, we are going to revise 4 lessons. The first lesson related to angles of triangles, second, congruent triangles, then proving triangles congruent by SSS, SAS, then ASA, AAS. So we are using the postulates of congruence. Now let's start. Question number 1. What is measure of angle NRP? NRP is this one. Of course, these angles form linear pair, so directly you can say that they are forming 180 degrees, so it is 180 minus 34, which is 146. Next, measure of angle DFG. DFG is this angle, and as you see, this is an exterior angle. The measure of exterior angle is equal to the sum of the remote interior angle. So simply you can just add the remote الابعاد. So it is 32 plus 46, which is 78. What is a measure of angle C given the condition? Triangle ABC, I will sketch it, ABC. For example, this is A, B, C. A is 100, angle B is 20. What is measure of angle C? طبعا the triangle sum theorem says that the sum of interior angles of any triangle is 180. So we will add 20 plus 100 and subtract the sum from 180. أكيد باقي بتكمل ال 180 and the result will be 60 degrees. In triangle JKL, we don't know how much is J. So let's see. But yeah, but he said that measure of angle J is more than 90. More than 90, so this is something like this, obtuse angle يعني. This is obtuse, so this is J, this is more than 90. So K and L are what? K and L should be acute. They should be acute. We cannot have more than one obtuse angle in a triangle. If measure of angle J, if other question equals to 90 exactly, then other angles will be acute and complementary. يعني there's some أكيد 90 الباقيين إذا كان 90, if it is 90, if not خلاص, if it is only obtuse, then acute, others should be acute. What is measure of angle CBD? CBD is this one. What are we going to do? First, finding this angle, try to find as much as you can. This will be 100 for sure, صح? Linear pair. Now we are looking at this triangle with angle 100 and other is 25. So this angle will be adding 25 plus 100, subtracting from 180, it will be 55. And this is the needed one. In triangle FGH, measure of angle H is 2 or twice measure of angle G. Measure of angle G is 3 times measure of angle F. What is measure of angle F? So I will assume measure of angle F to be X. So measure of angle G is 3 times the X. Now measure of angle H is 2 measure of angle G. But measure of angle G is 3x. Now we have here, this is 6x. Both are, are interior angles of the triangle FGH. So the sum of these angles is 180. That means x plus 3x plus 6x is 180, and we will solve for x. Now, if you solve, it will be 1 plus 3, 4, 10x. And that means measure of angle F we assumed earlier is the same as x, which is 18 degrees. Use the diagram, select all valid congruence statements. What are the congruence statements that we have here? Now, angle F and angle R are congruent. They are not. This is one arc, this is 3 arcs, wrong. GH, TR, GH, 2 ticks, TR, 2 ticks, yes, correct. Same number of ticks. C, triangle GHF is congruent to triangle TRS. If this is so, that means GH should be congruent to TR, GF congruent to TS, HF is congruent to RS, and this is okay. That means this is also correct. D, angle G is congruent to angle T. Yes, both have 2 arcs. Others are not okay, not good, yani not the right ones. If a series of rigid motions map triangle PQR through triangle LMN, then measure of angle Q equals to what? QR equals to what? Then we have to realize that if the rigid motions, yani reflection, rotation, or whatever, leads that this maps to that, that means they should be congruent. That means triangle PQR is congruent to triangle LMN because it's rigid motion. That means angle Q should be congruent to angle M. In our case, angle M is equal to 38. So you'll copy it. QR congruent to MN. MN in our case has the length of 7. So this should be 7. As simple as that. Just understand what is going on. Which postulate can be used to show that triangle ABC is congruent to triangle GFH? Now, as you see here, all sides, corresponding sides are congruent. One tick relates to one tick here, 3 here, 3 here, 2 here, 2 here. So SSS is the valid one. This angle is given to be 40 between 2 given sides. So if we want this angle to be used properly, then this should be given as 40. But since it's not given, we cannot use SAS. So only SSS can be used here. In triangle ABC and PQR, it is known that, and this is, I will just draw ABC and other triangle PQR. It is known that AB is congruent to PQ and angle A is congruent to angle P. Complete the statement if angle C is congruent to angle R, angle C is congruent to angle R, then we can use AAS or SSS or whatever. We have here angle and then another angle and then angle, then side. Same order there, angle, angle, side. That means we have angle, angle, SAAS theorem. Which triangle is congruent to triangle FGH? In order, FGH means FG should be congruent to TS. صح? So we have to start with TS. يبقى هذه أكيد إيه؟ FG correspond to TS R. Now compare the sides, they should be corresponding sides congruent. Which triangle must be congruent to triangle ABC? As you see here, we have angle, side, and angle, then side, 4, then angle, then 6. The only one is compatible with A. For B, مثلا, for B, the angle is not between the sides given. The angle should be between the sides included. This is the only correct one, A. Match each postulate or theorem to the pair triangles whose congruence justify is justified by the postulate or theorem, or state that not enough information is given to determine congruence. First one, B. ASA, because here we have here angle, then side, then angle. So angle, side, angle. Very clear. Now for this one, it is side, then angle. ما في شيء. There is nothing called side angle. ما في. There is nothing. Side angle is not there. No side angle. So here, not enough information. So this is what, D? Yeah, D. And this one was B. For the first here, for the triangle, we have angle, then side. Angle, then side. AAS, so it's C. AAS, and that's all. If triangle ABE is congruent to CDE, what is the value of X? Now, let's look at the angles here. Angle A should be congruent to angle C. This is angle A, and this is angle C. So use the statement of congruence properly and clearly. So measure of angle A is equal to measure of angle C, and we will replace. And if you solve, this will be 15. A flagpole is supported by two cables of equal length. So this is congruent to that. AD is congruent to CD. Come on, this one is congruent to this one. Then triangles are congruent by what? ASA, SAS so far. Both A and AR. So he is giving you measure of A and C, 55 here. This is 55, this is 55. So which one we can use here? Since this is side, and then angle, and then side, and we have the same situation here, then they are congruent by side, angle, side. Now, since command, we have also an idea that this side is common, BD is common between the two triangles. So we have three congruent corresponding sides. That means we have here SSS can be used. So for this case, we have SAS and SSS. Use the following diagram to answer these parts. Given BAC is congruent to DAC, BCA is congruent to DCA. Now let's continue here. This is missing statement here. If you have reflexive property of congruence, then there is a common side definitely. And this common side is AC as you see. And that means we will use this to fill in the blank. Last statement, the missing one, which is here, we need to find the theory or the postulate that have been used here. And he has been here triangle angle BAC. We have used an angle congruent to that. We have used also BCA, yani this angle is congruent to this, and the common side is between them. So as you see here, we have angle, then side, then angle. So angle, side, angle is the missing reason here. So here we have angle, side, angle, and we will use it here. Be careful when you are filling the blanks, because actually they are easy. For exercise 17 and 18, use the following diagram. We will fill in the blank. Now, what is necessarily here to know why the triangles are congruent? He mentioned the reasons, the statements before. He mentioned all the sides, and this is the common side, so definitely this will be side, side, side. After proving that triangles congruent, so we are using here SSS, after proving the triangles congruent, any other angle will be congruent to the corresponding angle in the other triangle. This means we are using CPCTC, which means corresponding parts of congruent triangles are congruent. So this is the result of congruence. And that means we are going to fill the blank by D here and A here. A here is the CPCTC. So we are just choosing them in the proper way. Which additional statement are required to prove triangle ABC? Let's sketch ABC, and the triangle here is LKM in order. Using SAS. SAS means we need two sides and angle between them. If you know that angle L is congruent to angle A. So what else we need? Since we have chosen this angle, that means you need to choose that this side is congruent to this side and this side is congruent to this side. We don't have other choice. That means we have to choose C. AB is congruent to LK, and we have E, which is AC, is congruent to LM. In triangle ABC, measure of angle A is 35, AB is 4, BC is 2.5. In the other triangle, DEF, measure of angle D is 35, DE is 4, and EF is 2.5. Is triangle ABC congruent to DEF? Is there anything shows that? As you see here, the angles is there, but the sides given are not put properly. Yani we need to have this side. If this side was given to be congruent to that, it will be okay, because we are looking for side angle side. There is nothing called side angle here. This is side angle. So no, because the information is not enough information. We need AC to be congruent to DF. This is needed. If LM is congruent to LN, what is X? LM is congruent to LN. So this is also 2x plus 5. Okay, since this side is congruent to that, so these angles are congruent definitely. Now we have one angle given, which is 60. That means these angles together will form 180 minus 60, which is 120, and they will be equal since these sides are congruent. Each of them, so measure of angle N is equal to measure of angle M is 120 divided by 2, which is 60. Now we end up with 60, 60, 60, and this is equilateral triangle. That means all sides are equal. That means 2x plus 5 will be equal to 4x minus 9, and you will solve the equation to end up with x equals to 7. So that's because the triangle is equilateral. A roof truss for new cabin manufactured uses cross pieces placed in the sacred precise angles. If measure of angle 2 is 3x, this is the triangle here. And as you see here, angle 1 is outside. This is exterior angle. Angle 2 is given to be this value. 3 is this value. Measure of angle 1 is given as well. So the first important thing is to the equation, set the equation properly. So measure of angle 1, because it's an exterior angle, is equal to measure of angle 2 plus measure of angle 3. So measure of angle 1 will be 6x equal measure of angle 2 plus measure of angle 3, which is 7x minus 26. And when you solve the equation, x is 26. Easy. Look out. Tower sits on a network of struts and posts. Leslie measured 3 angles of the tower. Let's see these angles. Yes, these are the angles here. We have 2, 3, and 1. Yes. And as you see, this is similar to the first one or the previous equation or the first question. We have angle 1, look outside. So it's an exterior angle. So measure of angle 1 here is equal to measure of angle 2 plus measure of angle 3. Remember the theory. The measure of exterior angle is equal to the sum of the remote interior angles. الخارجية تساوي مجموع الزاويتين البعيدتين الداخليتين. So we will replace. And you can solve. This is x. He is asking about angle 1, so we need to replace. Don't forget, read the question carefully. Measure of angle 1 is 6x plus 9. So 6 times 11 plus 9, 66 plus 9, which is 75. Yes. Next, find the measure of angle F here. Same here. Measure of angle F, the exterior angle, is equal to x plus x. So 54 is 2x. So x is 27. Easy. Exterior angle. In the diagram below, triangles are congruent, mentioned clearly. Find AC. Since triangles are congruent, then by CPCTC, as a result of congruence, AC is equal to AB. That means 6x plus 8 is equal to 2x plus 12. When you solve, x will be 1. Now he is asking to find AC. Remember, AC is replace 2x plus 12, replacing x by 1. So it is 14. AC is 14. In the below diagram, triangle ABC is congruent to triangle FDE. Find the value of x. Now let's start with the easy part. It's very clear here that angle B is equal to angle D. So measure of angle B is equal to measure of angle D as a result of statement of congruence. So Y equals 48. Okay, let's do it in order. Measure of angle B, 48. Measure of angle D given to be Y. So Y is 48. Done with Y. Now, how can I find X? X is mentioned here as a part of angle F. So we will check the statement of the congruence again here. Angle F will be congruent to angle A. So angle F equal to A, but we don't know A. Yes, we don't know A, but we can find it because the sum of interior angles is 180. So we add 48 plus 108 and subtract the result from 180. You will find A, which is 24. Since A is 24, so angle F, which is 2x minus y, is 24. Let's take y, replace the y, which we have found before, 48. And we will solve. So x is 36. We have two triangles are congruent mentioned here in order. Remember, find the value of y. Okay, let's see here what can we do. Where is y found? Y is here in RS. So here we have RS. Type. RS is congruent to TV. TV, where's TV? This is TV, 20. So in order, no need to rotate and check which one is congruent to it. Just use the congruent statement properly. So we have here RS is equal to TV. We will replace So 2y is 22, y is 11. If you are asked to find x, what will you do? X here is the measure of angle T, صح? If you are asked. But angle T corresponds to angle R. R is not given here, صح? But you can find it. Why? This is the triangle that R is located at. This is 90 and this is 74. We can find R by subtracting 90 minus 74, 16. So X is 16. You can check. It's not required, but you can find it. Answer the below questions. We are going to complete the 2-column proof here. Of course, here you have to use the given information at the beginning. So whenever you see given, check what is given exactly. Here we have to copy the given information. The first one was not copied, so we will copy it. EF is equal to GH. The second one was copied, lines are parallel. Now, angle FEH is this one, is congruent to angle GHE. As you see here, it looks like Z letter. That means they have used alternate interior angles theorem. Now, here reason is there, reflexive property. When you see reflexive property, that means there is a common side or common angle. And this side, it's very clear that it is common between the two triangles. That means I will copy the side. EH will be congruent to itself to fill in the blank. Now, what is the relation between this and that? This statement, statement 1 to statement 5, as you see, are the same, but they have converted the equal statement into congruent statement. And that's why we say the definition of congruent statement. Yani any congruent statements are equal in measure, or any equal in measure sides are congruent. Finally, lastly, we need to justify what is the postulate used to prove that a triangle is congruent. We have used that side EF is congruent to GH. We have used one common side, which is that one at the midway, or not the midway between them, and we have angle between. So we have used side, angle, side, and we will write the theory here, side, angle, side. Given QM is equal to SD, shown here, QT is congruent to SV, shown here. Which one additional information needed to apply the SAS? SAS means I need angle between these two sides. Yani I need this angle to be congruent to this angle between two given sides here. So simply you will write angle Q should be congruent to angle S. Very easy. Answer the below question. We will also fill in the blank here, fill the proof. Given, if we copy the given thing here, the second given is not copied, so I will copy that AB is parallel to DC. Now, angle ABC is congruent to angle DCB. What's the reason? As you see, the Z is very clear here. So we know that it's alternate interior angles theorem. We also have BC is common to itself. This is, of course, reflexive property of congruence. Finally, we have to mention the triangle since he mentioned that it is AS, so we will write the triangles in the right way. So if you start by triangles, we will copy triangle ABC is congruent to triangle DCB, and this is exactly the statement needed to be proven. This is another one. Given that QM had the same question as we have done here, but he wants the triangle to be congruent by SSS. Since we need three sides, so we will mention the missing side. What is missing? It is MT should be congruent to VD or DV. to have SSS postulate. Complete the two-column proof. V is the midpoint of WX, so we will copy this statement exactly. And if you know that V is the midpoint of this WX, that means it cuts the segment into two congruent parts. And it's the same also for the other one. It's not always the case, but for this, it is the midpoint of both. So this is also congruent to that. And that's why this is the conclusion that he draw here. No, YV is congruent to VZ, WV is congruent to XV, and that is because of the definition of the midpoint. We know also that this angle is congruent to that, and that's why angle YVW is congruent to ZVX, because they are vertical angles. So vertical angles theorem. So we have side, angle, side, one after the other. That means the triangles are congruent by side, angle, side, and we will copy the needed statement. Which is that one. Last one, just copy. Find the measure of angle C. What is the measure of angle C? Now, as you see here, angle C is congruent to angle what? This is angle C. It will be congruent to angle F. Do you know any of them? No. Yes. And this angle has one arc, so this is exactly the same as this one. So this is 83 as well. Okay. Now, the missing angle, which is F here, will be 180 minus 42 plus 83, right? Which is 55. So this is 55. So measure of angle C is equal to measure of angle F, which is 55. Very easy. So find E from that triangle because of the information given, find the corresponding angles, and then find the missing one. Now, given LMN is congruent to QSR, what is the value of X? So from here, angle M is congruent to angle S in order. So M is congruent to S. So I will write the statement or the equation, 3x plus 22 is equals to 70. X is 16. Easy. Tilma came to a river during a hike, and she wanted to estimate the distance across it. She held her walking stick AB vertically. So since this is vertically, this is perpendicular to the ground or the edge of the river. She sighted along the top of the stick across the river to the base of 3T. Then she turned without changing the angle of her head and sighted along the top of the stick or rock to a rock located at her side to the river. Question: explain why triangle ABT will be congruent to triangle, the other one, AB, whatever, ABR. This is missing. Yes, why they are congruent. Now, first, angle BAT is congruent to angle BAR. Why? Because she said, or he said, that there is no change in the direction. That means BAT is congruent to BAR. Number two, we have AB, as usual, is congruent to itself using reflexive property. Number three, we have angle ABR and angle ABD, ABT are right. Because he said that it's vertical. That means angle ABR is congruent. يعني each one of them is right, صح? So that means angle ABR is congruent to angle ABT because all right angles are congruent. What happened now? We have angle, and side between them. So the triangles ABT is congruent to triangle ABR by angle, side, angle. Now Delma finds that it takes 27 paces to walk from her current location to the rock. She also knows that each of her paces is 14 inches long. Explain how she can use this information to estimate the distance across the river. Now, first, we will find BR. Now, as you see here, BR is this one. From the current location to the rock is equal to 27 by 14 because each pace, one pace is equal to 14 inches. So we have 27 paces equals how many inches? So we'll multiply that, you will have 378 inches. Now in foot, we know that 1 foot is equal 12 inches. That means we want this distance 378 in feet. So we divide by 12, we will have 31.5 feet. This is what BR or RB. Now RB is congruent to أكيد to BT because the triangles are congruent. So by CPCTC, since the triangles are congruent, so أكيد the other one will be congruent. So that means BT is the same as BR, which is 31.5 feet, which is the same as the this is by CPCTC, and that means this is the width of the river, or the distance across the river needed. So the distance needed is the same as that. With that, we end this nice revision. Good luck for you all. أتمنى لكم وأرجو لكم حظا سعيدا وإجابة موفقة، وكل عام وأنتم بخير. إلى اللقاء.